video, we are going to explain about a project titled Improving Children's Speech Recognition Through Feature Learning from Raw Speech Signal. So now coming to the introduction part, improving children's speech recognition through feature learning from raw speech signals represents a promising avenue for advancing speech technology. By addressing the specific challenges posed by young users and harnessing the power of deep learning, this approach holds the potential to revolutionize how children interact with and benefit from speech recognition systems. The future implications could be transformative, enhancing educational tools, language acquisition, and fostering more inclusive and engaging communication experiences for children worldwide. Deep learning architectures such as convolutional neural networks and recurrent neural networks play a central role in this feature learning process, facilitating automatic pattern recognition and generalization. So now coming to the objective part for this project is to create a more inclusive and effective speech recognition system that can be integrated into various educational and interactive applications for children. By improving the technology's ability to understand and interact with young users, the research seeks to enhance language learning, communications and accessibility for children in educational settings, language development programs, and other speech-related applications. By directly extracting relevant patterns and information from the raw audio input, the system can better capture the unique characteristics of children's speech, such as higher pitch, shorter utterances, and evolving phonological attributes. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirement, first, operating system as Windows is required. Processor i5 and above. Minimum 4 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first, upload children's and adult speech dataset. The first step in improving children's speech recognition is to gather a comprehensive dataset comprising audio recordings of both children and adult speakers. This dataset should encompass a diverse range of speakers, including various ages, genders, and accents. Collecting speech samples from children is crucial to account for the unique vocal characteristics and development stages of their speech. Similarly, adult speech data serves as a benchmark for comparison and training purposes. Second, extract signal features from audio dataset. With the audio dataset in hand, the next step is to extract relevant signal features from each recording. Commonly used techniques include male frequency capsular coefficients, that is MFCC, spectrograms, and other time frequency representations. These features help represent the essential information in the audio signal, making it more suitable for input into machine learning algorithms. Third, run CNN algorithm. Having extracted the signal features, the dataset is now ready for training a convolutional neural network, that is CNN. CNNs are well suited for pattern recognition tasks such as speech recognition due to their ability to automatically learn hierarchical features from the input data. Fourth, upload test audio and recognize the speaker. After successfully training the CNN, the next step is to upload a test audio sample which the system will attempt to recognize and attribute to either a child or an adult speaker. This test audio should be distinct from the data used for training to ensure a fair evaluation of the model's generalization capabilities. The model applies the same feature extraction process to the test audio, transforming it into a suitable input format for the CNN. Fifth, exit. Once the test audio has been processed and the model has made its prediction, the system completes its task and the user can review the result. The system can then be exited and further evaluations or improvements can be made as needed based on the performance and feedback received. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we have two folders, that are adults and children. In these two folders we are containing some dataset over here. And another folder named as model. In this we are containing .npy files and .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks such as making predictions on new data or performing specific operations. Another folder named as test speech. In this folder we are containing some audio over here. And here this is the Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload children's and adult speech dataset button to upload the dataset. Then I am selecting this dataset folder and now click on select folder button to load the dataset. So here on this screen, dataset loaded, and now click on extract signal features from audio dataset button to extract signal features from dataset. So here on this screen, dataset contains total 123 speech files, and from each file we are extracting 14 important signal features, and this feature will be input to CNN to train the model. Now speech features are ready, and now click on run CNN algorithm button to train CNN model. So here on this screen, CNN model generated on children and adult speech dataset, and we got its accuracy as 100% over here. So now click on upload test audio and recognize speaker button. So here I am uploading this audio over here, and now click on open button. So here on this screen you can see that speaker identifies as adult, and similarly you can upload and other files and test it. And by clicking on exit button, you can exit with this application over here. Now coming to the conclusion part. In the long run, the advancements in improving children's speech recognition could lead to more initiative and responsive technologies, enriching the lives of children worldwide and empowering them to communicate effectively with machines. As researchers continue to refine and expand upon this approach, the future holds exciting prospects for bridging the gap between children and technology, creating a brighter and more interconnected world for the generations to come. By providing a seamless and natural interaction with technology, young users can benefit from improved language learning experiences, increased accessibility, and enhanced communication ability.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.